Hey everybody, we're on question number 3. I know Ms. Kirk did number 2 with you, and now we're going to move to Pythagorean theorem. The following question, you see diagrams, don't you? And immediately I hope your mind starts to think, oh, that's right, the modeling. And modeling, all it was when we used Pythagorean theorem, the modeling meant, well, first, what is the formula for Pythagorean theorem? A squared, I hear ya, B squared, I know, is always equal to C squared. So what does that mean? We know that if we have a right triangle, okay, if that is a right triangle, what is C? Opposite the 90-degree angle. The two legs are A and B. And so this formula means that the square that is created from the length, which is side, B squared equals to the area of this triangle, okay? So your side length is B, but the area is B squared. And vice versa, the hypotenuse is going to be one big square. This would be C squared, okay? And what about A? You have A squared. Okay, so when we work this, what do we know? That these two squares added up must be equal to the opposing larger square. Okay, the hypotenuse always creates the larger square. Okay, so what would be the first step? I'm going to look at my problem. And the question actually states, which square should Victoria use to complete the model? Did she say that these two were legs? Did she say that this was the square off of the hypotenuse? No. But all we know is from Pythagorean theorem that the two legs of any, the squares that are created off of the two legs should be equal to the square, the area of the square off of the hypotenuse. So my first step, I might want to find the area, shouldn't I? So let's look at this. Oh, my bad. Hopefully that didn't pop up on your screen. I need to find the length of this side. Count with me. 1, 2, 3, 4, 5. You said it. 6. So the area of this squared should be 6 squared. And what does that equal? 6 times 6. My apologies for my dog, is equal to 36. So that means that the area of this square is equal to 36. So what about this larger one? 1, 2, count with me, 3, 4, 5, 6, 7, 8, 9, 10. So 10 squared is 10 times 10. Okay, and that is equal to 100. I'll put the dog out in a minute after I finish this video. All right, so I found these two, but I have no idea if they're the hypotenuse. I have no idea if they're the two legs. So what I really need to do is find which two squares, or maybe it's this one and this one, I have no idea, and set them up to be equal to each other. So we need to look at A, B, C, and D, and we need to do the same process of counting the length of the side. So with me, 1, 2, 3, 4, 5, 6, 7, 8. And that is equal to 8 times 8. And it equals 8 times 8. You're right, 64. All right, you can go ahead and count ahead. 3, 4, 5, 6 squared is equal to 6 times 6 is equal to 36. Okay, I'm going to go ahead and just put those in. Do the last C and D. 2, 4, 6, 8, 10, 12. And that equals to 144. Whoops, my apologies. And the last one, 2, 4, 6, 8, and 10. Okay, now's where the thinking part comes in. How would you go about doing it? Well, we know that the two smaller squares should be equal. When we add, the two small squares should be equal to the larger one. Okay? So if we set that up, that means, so out of these three, which two are the smaller ones? Absolutely. So I'm going to use this one plus this one, because we know that a squared plus b squared is equal to c squared. And I already squared them. And if this is our c, it should be 100. 36 plus 64. Okay, don't you love it when the first one always works out? Technically, the a would be my answer, but are you going to stop there? Absolutely not. We're going to go through the rest, the other three, and either prove or disprove that they are correct or incorrect. So, which two are the smaller ones? These two. Now, can you have two legs that are equal? But straight off the bat, I know that 36 plus 36 does not equal 100. So this one cannot be a solution. Now, which one out of these three, which one is the larger one? That's going to be my C, this square right here. And it's going to be equal to my two smaller squares added together. And we know that 136 does not equal 144. I can eliminate this choice, as well as the B that I had before. All right, and we know that you cannot have two. You need to have one big square. So this one doesn't make sense. Okay, which one's my hypotenuse? They're both equal. I can eliminate D. And your answer choice is A.